So, good afternoon. It's very nice to be here and make it to Fosdem at last. And thank you very much to everyone who's been organising this and to Girlfriend. Nice to be here. So, today is to take you on it is a paradigm language, just like Perl 5, but we try and do a bunch of paradigms in a more interesting and sort of create a bit more infrastructure for some of them. So, for example, we have a lot more syntax, things related to, say, object orientation. It's gradually tight, and that is quite a departure from Perl 5, where focused on having a language where you can build your way up from something very small into something very big, and refactoring as you go along is something that it just feels very natural. And I have to say, of all the languages I've worked with, I find evolving my Perl 6 code to be one of the easiest languages to do that evolution. So the specification of the language is actually a test suite. Meaning that unlike 5, we're very open to multiple implementations. There's a standard grammar, which is actually written in Perl 6 as well. And there's a great community around this. Part of the joy of being involved with a decidedly long and sometimes quite tiring and challenging project is that there's a lot of really great people involved in this as well. So that's a basic sort of little look at what sort of language we're talking about and what sort of project we're talking about. What I sort of want to do today is where we're at, and that means we're actually going to go and build as someone who's working on the compiler, how it actually feels to be a user of the language, and I think it's really important to do that from time to time. So we try and dog food a few things. For example, the debugger for Rakudo Perl 6 is actually written in Perl 6. So we've actually been building a lot of the pieces that we need to build the language in the language itself. And last year I actually used Perl 6 over at a real world client. It was, to be honest, a case where they didn't really care what I used, they just cared about getting results. I used Perl 6 to basically throw away 500,000 lines of their code base without them noticing, apart from the build process. Again, it's safe. So, well, I was kind of thinking, what can I do with Perl 6 that we can fit in an hour and that sort of lets us explore the language in some kind of interesting way. And for various reasons, I've been looking for very big data sets or interesting data sets that you can find around the web. And one of the curious ones I came across was a huge archive of historical global temperature data. And I was like, oh, that sounds interesting. And of course, it's not in JSON or XML, it's just in this big heap of junk, which is going to be a little bit of fun to try and get the data out of. And what I wanted to do is just explore it a little bit. I ain't got any agenda here or anything like that. It was just a sort of typical data munging task, and I thought, yeah, okay, let's see how we can do. So this is the kind of thing that you get, okay? This is a... does anyone know where Jan Mayen is?
It's an island.
It's an island. Yep, about where?
Norway.
Yes, it's a Norwegian. Yeah, it's a Norwegian island. And that's actually a very, very long way from Norway. It's in the middle of the Atlantic. It is actually reckoned to be the place on Earth that's inhabited with about the least sunshine, because it's basically cloudy all the time and cold. So it hasn't done very well as a tourist destination. In fact, it basically is a military island with about 18 people there year round. So, I haven't been there or anything. But anyway, it's pretty cold, it seems. These are the average temperatures for each month of the year, okay? And it's a little bit chilly. So, I mean, the highest that you get is 7.2. And that's in a hot year, it seems. Basically, you get this data here, and it's a bunch of metadata at the top with a bunch of observations. So you kind of look at this and you're like, okay, let's try and actually pull the information out of here. Alrighty, so how do we do that? Well, Perl's always been very good at grabbing stuff out of text. The only problem is that by the end of doing a lot of this, a lot of the time the code devolves into this huge mass of regexes. They're really quite a bit of a pain to actually maintain. And recognizing this, in Perl 6, we actually put full support for grammars into the language. So instead of having to try and then move on to other parsing technologies, you can take your knowledge of regexes and then basically just extend it a little bit and be able to parse much more sophisticated languages. And this gives us a much better structured way of doing this. They're composable, so you can be parsing one language and then say, oh, we're in the middle of a bunch of, say, templating language, but here's a bit of SQL. Let's switch to a SQL parser for a while. Okay, we're done. Let's switch back. And they're also very extensible. You can actually subclass these parsers, and they're fairly easy to maintain as well. So let's take a little look at how we build such a thing. So we use the grammar keyword to introduce a grammar, and we give it a name. And what we're going to do is the hat and the dollar, you can probably guess. Okay, start of string, end of string. That's perfectly familiar. And then we have the plus there. That's the plus quantifier. I think you know from regexes for saying one or more. But what we do is instead of just going off and writing all the stuff to match, we basically call two other bits of regex. Okay? And what I'm doing is I'm describing the sort of overall structure of this. So I'm saying there's one or more key values at the top. Things like number is this, name is this. And then there's a bunch of observations, this section. Okay? So, what now? Well, let's do a key and a value. So what I'd like to do is not just parse this, but have a way of actually pulling all the information out of there. So what I'll do is I'll just bind to a named capture. That's what that bit of syntax is over there. Okay. So the key is going to be, and we'll just match a bunch of word characters. Okay. \w plus. Square brackets are not character class. They're just grouping. Okay. Now, what I then do is I'll match an equal sign. You can just put quotes around stuff to match it literally. We then will match some horizontal white space. Okay, and then anything that's not a new line, that gets us the value. Okay, so fine. That basically is going to let us pass the keys and values. Now, what next? Observations. That's the text obs. Potentially some white space. The files are not entirely very consistent. And then at least one observation. And an observation, what's an observation? Well, it's a year. That's a bunch of digits. Some white space, and this is cute. This is one or more temperatures, and this modulo thing here means separated by. Okay, so it takes the previous quantifier, the plus, and it says between them there should be this. Okay, so basically a bunch of numbers separated by white space. All right, and then what's a temperature? It's maybe negative. It's a digit, a dot, and some more digits. And that's it. That is a complete description of how to parse this text. Okay? And it's nicely broken up into small pieces, so we can understand what each of the little bits does. So, the question is, will it work? Well, let's see. 6M, 01, no. Thank you. Failed match. And the trouble with this, of course, is you're like, why didn't it work? And, when grammars don't work, you're kind of like this, because, and then you're like, well, what should we do? I mean, one of the nice things you can do is you can actually just go and write any closure you like inside of one of these production rules, okay? And it works very nicely. And we can just go and do say and just pull out those two things that we matched. And we could do that, but seriously, like use the debugger. So the debugger is much, much nicer for this. Okay, the debugger is actually built in Perl 6 for Perl 6. It knows about debugging all of the weird stuff. Begin blocks, code that you eval, you can step into, macros, regexes, and yes, grammars. Okay, so my thing didn't work, so I want to debug it. So instead of saying Perl 6 and that, we'll just put in debug, okay, and let's have a look. Okay, so what it does is it sort of brings me into here, and it sort of highlights this line of code, and when I hit that, it actually takes me into my grammar, and you can sort of see the yellow there, and it also has the bit of text that we're matching. And as I go through this, okay, we call key val, we call the key, we look for the \w plus, okay, and see number went green because we passed it. Okay, now that's fine, and what I'll do is I'm just gonna keep going through this, okay, so you can see om nom 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 nom, okay, as we go, and this is looking okay. Oh, did you see what happened? You see that we got the word start, but not year. Okay? What we did is we passed with \w plus to get the start, but then we weren't matching white space for the keys. Okay? So we missed out passing the year. Dope. Okay. So, well, that was a silly mistake. Let's fix it. Okay, so here it is. And that's not the right size for you to see it. There it is. Okay, and here, what am I going to do? I'm actually just going to say, well, it can be, let's do a character class, white space as well. Okay, and I think that this will fix it for us. So let's try it. And not going to do it under the debugger this time. We'll just go straight for it. Okay, and whoa, that's a lot of output. But you can see that it actually seems to pass the thing. And down here, what we're seeing is we have an observation, okay, and then we have the year, and we have all of the temperatures that have been pulled out. And it's actually gone and captured all of the structure of the data as well. So basically, you get the tree for free. Okay, you don't have to go and build up your own data structure if you want to start working with this information. So let's do something really simple, just straight off on that tree. So we pass this file, okay, the grammar, and then what I'm going to do is I'm going to look for the lowest and highest temperature that we ever observed in all of these observations at this weather station. So I start out looking for my lowest one and highest one, okay, and we just put infinity and minus infinity in there. And what I'm going to do is a for loop, and if you remember the structure of the grammar, at the top we look for observations, and the observations rule could match a bunch of observation, and it was quantified with plus, so we get an array. And I can loop over each of these, okay, that's just naming the variable that we're going to shove the thing we're iterating on into. And then all I need to do here is loop over the temperatures, okay, of that observation. And then here, you know, you can say things like plus equals, or, you know, minus equals, or multiply equals. And there's a min operator and a max operator that are infix. So you say this thing, min this, and you get back the smallest one. Well, you can do min equals and max equals. Okay, these are actually not really hard-coded into the language. They're generated. So if you introduce your own new infix operator, you get this for free. Okay, so with that, we can just quickly go through and find the lowest, the highest, say them down here at the end. Okay, so that works. And that wasn't too hard.
So why would you say, why is it $lowest min equals min something? Why wouldn't you just say lowest equals min brackets? I mean, that would be an old style syntax. Is that better? Am I understanding correctly? That is
well, the operator itself. Let's pull up a REPL. Okay, the operator itself, if I say 21 will do, min 42. Okay, I get that.
Right.
Okay, and which is 21. And the thing is that with all of these operators, you know how you have plus, you get to write plus equals instead. Okay, and if you want to do something like a plus equals 1, okay, well, you do a plus plus, well, 2, like that. Okay, and the min one is just the same case. I mean, we know that rewrites to a is a plus 2, and so a min equals b rewrites to a equals a min b. Okay, it's just completely productive. It's none of these operators, we call them meta operators. The things like the equals and negation, because they take existing operators and they basically just modify their behavior a little bit. And we'll see a few more of those. Okay, and they're completely regular. If you define your own new operator, you get them all for free.
So I guess what I was misunderstanding there is min is just between two values rather than operating on a list.
Correct. However, if you had a list, you can do a reduction. Okay, that's reduce. Okay, and that's completely regular as well. For example, that's how you ask if the whole list is numerically equal. Okay, you can do it with all of them. Okay, that's 10 factorial. Okay, yeah. So yeah, they're even useful. Okay, yes, go away. Okay, so ready.
You use the parse file method, but what if I want to parse std in, for example? We have a Thailander, and we don't have a path. So
yeah. Oh, there's a parse method which just takes a string.
No,
in
not
there.
a string. A Thailander.
Oh, you want to do it with a stream? That would be done with cat. We don't do lazy stuff on them yet.
Okay.
It's one of those. In the future, we will do stream parsing, but not now. So, and generally, unless you've got something insanely big, it's not a problem. But yeah, but you'd slurp it in. If it was some of a file handle, I'd just grammar.parse $file.slurp. Okay, and there we go.
You don't have something for progressive scan like an equivalent to sax?
No, it is not a progressive thing. Not at the moment. Yep, question there.
With the min equals and max equals, why do you have the unary plus in front of the t variable?
Oh, why do I have that there? That's a really good question. Min and max will do something based on whatever kind of type you have. So if you have a, min, b in their strings, okay, then you'll get string comparison. Because this is parsing the grammar, everything that comes out of it is a string. Okay, it's all text. Plus is how you nullify. And it's smart. If you do plus and the string is 42, you get an int. If you do plus and the string is 5.6, you get a rational back. So it gives you the narrow extensible type. Okay. So we pass, but this is sort of okay, but I'm not really happy yet. And the reason is that if the grammar changes or evolves with time, okay, then that structure of that tree is going to change, and this is not going to be the most maintainable of solutions. So if I want to sort of make this a little bit more maintainable, or just actually get a lot neater code out of this, rather than digging into hashes and arrays and so on, I'd really like to turn this into some kind of more interesting data structure. And what I'd actually like to do here is to actually create myself a little class I'll call it station data, that represents the temperature data from a station with a certain name in a certain country, and there is the array of data. And what we're going to do for the array of data is it's going to be a pair, okay, that takes a year and maps it to the list of 12 temperatures that we got observed that year. That's what data is going to be, an array of pairs. Now, all attributes are actually private and really named $!foo. So, you know, dollar and at and percent are all about essentially the structural type that you have. So if you put something like at x, okay, that's going to be an array, that's going to flatten in list context, just like you are used to it doing in Perl 5. And dollar is always an item and does not. But we have introduced these, we call them twidgels, okay, secondary sigils, which tell you something about the scope of a variable being unusual. And the exclamation mark one simply means this is private to the class. Now when you write $.name, it actually declares you a private thing, and then it makes you an accessor method. Okay? So your cost of private or public is whether you type dot or exclamation mark. So now that we have that, we need to actually build up instances of this class, and we're going to do some interesting stuff in there in a little bit. But the first thing that I need to do is actually find a way to take my grammar and the stuff that it's producing and actually grab out the interesting data and build up this class. Now to do it, we write something called actions. And rather than just go through the code, what I actually want to do is just take you into the debugger. It turns out the debugger has a REPL mode. Okay, so this can be really nice for understanding what on earth a bit of code does, because if I say for 1 to 5, okay, $x, and then we say $x, okay, and we just try this, then what we'll find is that we can now single step through it, okay, and we can even just look at the variables as well. Okay, we'll do exactly what we want. And if I just hit run, then that runs to the end. And now I've got a chance to do some more code. And of course, that returned me a bunch of booleans, because say in, we'll do that. Okay, fine. So let me just do this again, but show you grammars and actions. So let's try the grammar, a really, really simple one. And I'm going to have a top token. And what we're going to do is something really nice and straightforward. We're just going to match one or more integers separated by commas. Okay? And then token int, that's going to be some integer. Okay, so a really, really boring little grammar rule there. Okay, so it comes back and it tells me that I declared a grammar called G. Okay, that's what the G in brackets is there. So, what I can do is I can write a class A, and I can give it methods with the same name that take a match object. Now, we have a special variable $/. We don't have a lot of special variables in Perl 6. We have like 3 of them now, which is quite a good reduction. And yeah, $/ is the match one. And actually, it turns out that if you write $0 or $1 to get at the things you captured in a regex, that is now actually just syntax for indexing into that thing. Okay? And if you want to get at named ones, of course you can do, well, you could do that, okay? But we can write that now as that. But if it's into $/, then actually you can write it just as that. Okay, and pull the value straight out. So we've made it very convenient for you to work with these things that come out of grammars. Now, if I actually just in here, let's put some bogus statement in, okay, and then in here we write a method int, the same, okay, and again I'm just going to shove some bogus statement in, and we'll single step this. So what I'm going to do is g.parse, okay, and then I'm going to pass in 1, 2, okay, and I'm going to say use the actions class A. And at the end of this, we'll see what this does. So we're we're going to start parsing, and we go looking for an int, okay, and we look for the number, and as soon as we've matched it, we find ourselves inside of this action method. So it's a callback, okay? Every time you hit something, you get this callback, and you get to run some code. So I can actually look at what we captured, okay, by looking at $/, and it tells me it's a match, okay? And one property we have on there, you might see, is this AST one. And what this lets me do is associate some other object with this match. And I can do that just by writing make. And what I'm going to do is take that match object and just do plus $/, that is, make it a number, okay, turn the text we matched into a number. And this is one of the cute things about the debugger. You can actually just eval arbitrary code at any point you want in your program, okay, to tweak your program state. So you can tweak variables as you debug, if that helps you find your problem. So I'm going to just do make on that, okay, and if I look at this again, that 1 has now been stashed under this AST property. Now you might wonder why this is useful. And let me just go and we match the comma, we match \d again, okay, and I'm just going to again eval make plus $/, okay, and what we should now find is that we end up in the action method for top, at which point we can retrieve we can look at int 0, okay, that was the thing that we matched. Let me stringify it for you, just so you can, oops, we should put a P on there, okay, and the other one that we matched was that, but that actually is, if I say what is it, oop, not that, take that off, okay, that's a match object. But if I want to grab out that number that I left behind, okay, there's the 2, what is it? Okay, it's an int, so it's the thing we stored. So basically, we can pass things up the tree, okay, and construct whatever data structure we want out of them. So what I'm going to do in my, if we go back to this, is I have an action method written for all of my various tokens that I'm interested in. And let's start with key val because it's easy. We take the key, that turns it into a string. We take the val, and we turn that into a string, and then we make a pair. And in Perl 6, that pair constructor actually makes a pair object. Pairs are not just fat commas in 6. That actually is a pair object there. And we just pass it on up. What about observations? Well, first, a single year's observation. We make a pair. And then what we do is we take the set of temperatures, and all I want to do is map them into numbers. Okay? So at the moment, they're match objects that represent the bit of text we captured and the offsets and so on. And all I'm doing is I'm doing a map, what we can call map as a method. And that star.num is also worth just a moment's explanation, so let me do so. So you know that we could actually write a something like to star $_, okay? And then I can call A with 21, okay, and we get the answer. But it turns out that there's actually a, if I put an extra star there, okay, that also, and of course we could have done 2 plus that, okay, and you can actually have one that star.abs, okay, which is just going to call the abs method, absolute, on anything I pass in. So if I just do -5, then I get 5 out, okay? And this is a very, very neat bit of syntax. So we do that there. And a level up, okay, what I do is I take all of the observations. Remember, observation was plussed, it was quantified, so it's a plus quantifier, so we have lots of them. And what I do is I map them, and I get the AST, and then I didn't used to have this grep on the end, and then I found something really, really horrible. It turns out that a bunch of the data files indicate missing data by having a temperature of -99, which I guess will never actually happen on Earth, so at least not in the real world, but we need to filter them out. So all I've done here is I've just said, Okay, that made a pair. Okay, so dot value is getting the value of the pair, which is the list of numbers. And I'm saying none of them should be less than or equal to minus 99. Okay, so it kind of does what it reads like. Okay, values, none of them less than or equal to minus 99. Okay, so finally at the top we pull it all together. We take the station data class we call new, we get a default constructor for free, and what I'm going to do is I'm just going to pass in the info. Then all I'm doing here is taking the list of key values, okay, and doing dot hash, which turns them into a hash. So that's a way of turning a list of pairs into a hash. And then the observations, we just grab whatever we made here, which is the year pointing to the bunch of numbers. And then we have a station data object. Well, almost. You see, what we actually want in the station data object is the country, and the station name, and then the data. And the data is in pretty good shape, but the rest kind of isn't. So what we do is we write a build submethod. This is a non-inherited method, and you use them for infrastructural things. And build gets called with the named parameters passed to the constructor. And what we do with it is, well, what we do is you take them as named parameters. That's the signature syntax for named parameter. Okay, you put a colon before it. And here, what I'm doing is I'm binding to name. I'm just looking the name up and the country up. Okay, and then data. Now, that's fine, and that works. And it's perfectly acceptable Perl 6 code. However, I'm lazy, so let's do a couple of shortenings of this. The first thing is that you can actually just bind a parameter directly to an object attribute instead of binding it to a normal variable. So if I do that, then that line goes away, and that just goes in there, and we bind it straight into here. The other thing is that you can actually do data structure unpacking as well, meaning that I can take info, the hash, and I can then write another signature, which takes the hash, pulls out the name, and shoves it into the name attribute, and pulls out the country, and shoves it into the country attribute, and that star percent there means, and ignore all the rest of the values that are in the hash. Okay? So basically, we've done the whole thing with declarative programming there, rather than actually having to write any code. So, not bad. Alrighty. So, if we want to use the actions, okay, we can do so. We can just go and take the file, and we pass actions, and then I get .ast at the end. And if we run this one, let's do that. Okay. And I think, was it 02? Nope. I think 03. No, it was 04. Model actions. Okay. And if I do this, then whoop, there's a load of data. And you can see what this data is, perhaps. And let me just scroll way up here. Okay. And you can see it's a station data object whose name is Jan Mayen. The country is Norway. It's Norway, actually. And yeah, and here we have the array. So in 1921, these are the 12 temperatures. Okay, in 1922, these 12, and so on. Okay, so it works. So far, we have a grand total of 36 lines of code. Okay, we have a nice parser. We have a basic model class, and we have an action methods class just to. So what I'd like to do is to plot myself a little graph of the temperature each year over the different years that we have data for the station. Okay, so let's do a graph. So the first thing that I want to do is write myself a method, year means. And what we'll do in this method is we'll take, remember the thing I showed you with plus, okay, which adds a bunch of numbers together. And we'll just take that plus and we'll add together all the values, and then we'll use an array in numeric context, just like in Perl 5, it's the number of elements. Okay, so that's the mean. So, now we data, and we'll map it. And if you remember, it's a set of pairs. It's pairs of year. Now have a list of pairs and yield. There I found SVG plot, which makes me very happy because it claims that it plots graphs. Okay, great. So, by the way, module protocol is a good bit smaller than CPAN, but we're gradually building a set of modules. Do is get to GME and then pull it off. Okay, here are the means, and if you remember, that was a list of pairs from year to mean number, and you can actually plot multiple lines. This here is the year, okay, to go along the bottom of the graph, and here, because you can do multiple data sets, I just had to wrap that up in a couple of pairs of arrays, because we can actually give multiple lines, and we'll do some more different lines on two graphs later, on the same graph later on. We then take the name of the station and we say plot XY lines. And what happens if we run this? Do I dare demo this one? Let's see. Yearly means, okay. And if we do this, no, I don't dare do this one. I need to tell it where to find the libraries. Okay, and if we do that, then what should come out? Oh, and here's the really embarrassing bit. You will not believe what the default viewer for SVG is on this machine. Yeah, but look, it's a graph of means. Okay, so it works. So yeah, that was my backup in case the lifetime went horribly wrong. And I don't know what happened in the late 60s, but apparently it was pretty chilly. Does anyone actually know? Was it a remarkably cold winter?
Yeah.
Yeah? Okay. I wasn't there, so. Yeah, really. But anyway, there's the mean temperatures over at Jan Mayen. Okay? So, interesting enough. Alrighty, so what next? Oh, that was not what I wanted. That was what I wanted. Okay. So the thing is that I haven't just got data for individual stations. I've got loads and loads of them, okay? Tens of thousands. And what I want to do is just actually start looking at doing this by country. So we can actually plot a graph of the mean measurements across all the countries. Now, we start out just by doing this, okay? So we find a country, a class with a name, a set of stations. And at this point, another method to compute the means for an entire country. It's going to mostly duplicate the code that I wrote to write it properly. And I don't like to do it. So what I'm going to realize when I think about it is that actually having data for one station is just a special case of having it for lots of stations. So somehow we should hopefully be able to factor it like this. So what I'm going to do is I'm going to introduce a datasets method. And for stations, it just wraps the data up in an array and returns it. Okay, that is an array ref, so that will not flatten. And now, what I can do for my other one is I can introduce a datasets property. And all we're going to do in here is we're just going to map the stations into their data and do .item on it to stop it all splurting out into one big long list. Okay, I want to keep a list of them, so we have the data set for each station. So now I have a way of just asking for the data sets, that is the station's data, that I want to compute the mean on. So the question is, where should I actually write the method to do that? And one question you might come up with is, well, maybe a common base class. Okay, but no, that's not really what common base classes are for. Inheritance is really a mechanism for specializing behavior. And classes are really about responsibility. So in Perl 6, the thing that we provide you with for reduce default. Okay. What I can do is I can write the code. Years is the keys of the hash and a list of temperatures and what have you. And then all I need to do is move this over. Okay. So what are things you can get me way to infers is the way you incorporate the role, and what it basically does is copy the methods into the class. Okay, that's your best way of thinking about it. It's like copying the code stuff. Packaging object hierarchies. And of course Moose brings them very, very nicely in Perl 5, and naturally in Perl 6 we have them as well. Okay, so when I do this one, I get a graph like this. Okay, this is the graph of mean temperatures of all the stations in Norway over the years. And I looked at this and I'm like, my word, it's getting colder and colder in Norway. Of course, the data is not actually very legit. Okay, and you might wonder why it is. So I went digging, and what I realized is that there wasn't data for all the weather stations for all the years. And the two big drops in the graph are when they basically bought new stations online. And the thing about Norway is it's really, really big north to south once you count the islands. Okay, it starts below 60 degrees north, and once you get all the way up to Svalbard, you're like more than 80 degrees north. Norway is huge, or at least all the islands they count about. So, not that Svalbard is conquering it. But anyway, maybe the polar ones. But anyway, basically this was skewing the data, okay? Because we started with a bunch of weather stations in cold places, and then got some in the south of the country. What did they do for that? What they did in the end was just found a way to find the valid years. And just a cute little idiom here. You can actually put an initializer on an attribute, and it will run after all the rest of the object construction is done. Okay, if you haven't otherwise initialized this. So I just do a do, and I just go in here, and I just take, and all I'm doing here, you can see I'm getting the number of data sets. I'm going and counting how many data sets have a measurement for each of the years, and then I'm grepping out those where we counted the number of data sets for the year. Okay, and you might be able to find a cuter way to do that in Perl 6, but that at least is a fairly boring way of doing it, and it works. Okay, so now I could filter those out, and the graph looks a lot more sensible. Okay, but we had less years worth of data. But that one sort of shows the average is sort of crept up a little bit towards the end there, which is a little bit interesting. Okay. Finally, and I won't go too much through the code, but what I did at the end was I wanted to calculate the high and low temperatures. I just want to show you in this code that what I did was I factored out a way of taking a thing to do, just looping over the data sets, okay, skipping those that are not in a year that we have data from all the data sets for, and then I just call the thing to do and pass in the year and the temperature. And that ampersand there is just a way of taking a piece of code. Okay, it's the way that you can do the higher order programming stuff, which is kind of nice. And then what we need to do to actually do the lows, we can remember the min equals operator. Okay, so all I'm doing here is I'm doing year lows. We're going through all the valid years and all the data sets. We're getting the year, we're getting the temperatures. We're finding the minimum temperature for those. That actually appears on as a method on the array as well. And then I'm doing min equals to get this minimum factored in to that year list there. Okay? And what I will get at the end is I just need to take this hash, and I need to hand the years back in order, which means we take the hash and we sort the pairs from the hash by the key, that's the year, and we map out the values. Okay? And what I actually got out of this was a graph that looked like that, okay, for Norway. And you can see that the minimum temperature down here, the lows, actually seem to have maybe been rising a little bit. The highs haven't actually changed quite so much, it seems. And that means the overall effect on the mean is kind of not that much. It's kind of curious when you see this graph, and then you realize that that blue line is actually that line there. Okay, it's just that once you put it into perspective and see it on a graph like that, it looks a little bit less scary, which is basically presentation is everything. Okay, so all of the stuff that you've seen so far, I've actually been running Perl 6 here on a virtual machine called MoreVM, which is short for meta model on a runtime. It's basically a virtual machine built around meta object programming. And it actually has the fastest startup times of any of the Perl 6 implementations. So it starts faster, and it generally has the lowest memory use as well. Now, it's coming on very nicely. It's not too bad, and we haven't managed to crash it today. And it actually is fairly hard to do that with fairly long running stuff, because we did a guy called Nick Clark did some really great work with the garbage collector, basically torturing it and making it do a garbage collection run after every single object allocation. We then ran some very big tests on it, and they ran for like something like 3 weeks, and it hadn't actually crashed. So then we were fairly happy that it wasn't doing too badly. So we've really been torturing the thing. Now, the other thing that you can do is run it on the Java virtual machine. Now, there's some pros and cons. The pros are that it often, once it gets going, tends to be a decent bit faster. I don't have a number comparing JVM against MoreVM, but certainly there was one guy who took his code that he was running with Perl 6 on the Parrot virtual machine, ran it on the JVM, and it ran 40 times faster. Okay, so this can be quite a big speed up. And you might wonder how hard it is to take the Perl 6 code we've written and run it on the JVM instead. And you might have been noticing I've been invoking it as Perl 6M, and it turns out that all I have to do in order to run it on the JVM instead is to, let's actually just go for one of the simpler ones. Okay, let's go for model actions, and let's just do Perl 6J instead. Okay, now the startup time is incredible. However, Okay, finally. So once it gets going and its JIT compiler goes to work, it often actually comes out and gets ahead by potentially quite a long way. So if you have long-running stuff, this can potentially be quite a big win. Now, one of the other reasons that we really wanted to be on the JVM, other than the fact that basically every other language is there, so we should probably be as well, is that the JVM is a place where we can run code in parallel, and it's very, very mature about that. It's a very normal thing to write multi-threaded code in, say, Java. And when we wanted to get the Perl 6 concurrency features and really have a nice stable VM to build them on and test them on, and that basically did this stuff in the real world already, very big machines, and the JVM was kind of a natural place. Now, what I want to show you, just to finish this session off, is to actually show you how difficult it is to take the program that we have written, and you've just seen me run it on the JVM, and the full thing works as well. Okay, and then we're going to actually just parallelize it. We're going to make it so that it can run on multiple cores and crunch through this big data set in parallel. So, here is the code that goes over a list of directories, the data, and then goes over each subdirectory, okay, and it passes it. So this is basically going through all the directories, all the subdirectories, all the files, passing them, okay, and it's doing it sequentially. So let's do it in parallel. And the mechanism we're going to use, we've got various ways of doing these things in Perl 6, but the mechanism we're going to use is called promises, because they're the most natural way of doing this one. And I just want to show you what a promise is. So here, what I'm going to do is I'm just going to call start, and I'm going to give it a block of code which basically takes the numbers from 1 to infinity and greps them, and you'll be glad to know that's a lazy list, okay? And then we just test them for primality, and I'm looking for the 5,000th prime. And I'm just going to get that and shove that bit of work off on another CPU core, and I'm just going to look at the status of this promise, okay? And you'll see it turns from planned to kept. So it's actually been working away on another CPU core here while I've been playing in the REPL, and at this point it's got a result for me. And that is the 5,000th prime, well, 5,001st if we're doing from 1, I guess. Okay, so how hard is it then to take this and parallelize it? It's that, okay? And we only need to parallelize it so far. Okay, there's no point going overboard and giving it loads and loads of individual tasks to schedule. So what I'll do is I'll actually just start in there, okay, and then what it does here is it actually does this piece of work asynchronously, and it gives me back a promise representing it. So what this loop does is it basically results in a list of promises, okay, for each of the top level directories and the work, and then I just say await, and that just waits for all of them to be done, and that's it. Okay, and we can do a very similar trick for the graphs. What we'll do is we'll just await, do for all the countries, start, okay, say we wrote the graph, and then we're done. So again, the only thing I've done to turn this into a parallel program is just start there and await. And of course, we got lucky in this case because the sort of opportunity for concurrency in this program was very, very evident. Now, of course, the question is, does this actually use all the cores? And the answer when I did this on my quad-core hyper-threaded box at home is, oh yes, it did. Okay, so yeah, this is actually genuinely doing that. Now, of course, the question is it actually any faster wall clock time? Okay, because it could just be using all the cores but wasting them completely. And I'm glad to say that it's a quad-core machine, and I got more than 3 times speed up on it just by dropping these 2 things in. Okay, so it was actually, this is the parallel one, okay, and it's less than 1/3 of the height of that, which on a quad-core machine is pretty fast. So we got a reasonable speed up. Okay, so what is the state of Perl 6? That's some good news. I think Perl 6 is a fairly nice, expressive, and powerful language. you already can build some fairly interesting stuff on it, just like we've done today. In the process of building this, I really did not run into much in the way of bugs. I did run into one, which was actually a bug in the debugger, believe it or not. So I had to fix that one for one of the demos. But other than that, this was fine. And I really did just take the code that I wrote on MoreVM and just run it on the JVM, and it all did just work. And that really is a very positive thing, because it tells us that our strategy of using a test suite as the specification and then a formal grammar to specify the syntax, and that grammar actually being in Perl 6 as well, is actually working out as hoped. It's actually letting us have multiple backends for the language to run on. Feature-wise, hopefully you've got the impression from this that I've been able to show you a very wide range of things. We've been doing parsing with grammars, we've been doing object-oriented programming, we're doing bits of higher-order programming, we've used lots and lots of built-ins, we've pulled in modules, we've done a bunch of parallel stuff at the end. And feature-wise, things are in pretty decent shape. Really, there's a lot of things you can do today. And at this point, the question of a lot of things that are left in the spec that are not there yet is, well, do we really need them to declare 6.0? And I think the answer for a lot of them that we're still missing is going to be, actually, no, we don't. So that's all the good stuff. Of course, there's a bunch of reasons why I'm not going to stand here and tell you you should now go and use Perl 6 for everything you do, okay? Because I hope at some point I can say this, but right now there's a few reasons to hold back a little bit. One of the big ones at the moment is speed. And in the true sense of, make it work, then make it fast. We've been doing the make it work. And as you can see, a lot of stuff does work. A lot of people find that it's not fast enough for them yet. It really depends what you're doing. On the JVM, things are a lot better once it gets going. For scripting stuff, we got startup time down a good bit. There's also a good bit of memory work that we want to do as well. And we've got some quite interesting stuff going on in that space right now. The other big thing that is a work in progress at the moment is getting access to CPAN. We've had various prototypes of this in the past, and they were educational, but in the end didn't quite sort of get there. I'm very hopeful for the current effort, which is looking very promising. And you'll find that tutorial-wise, things are a little bit sparse. The reference docs are not too bad, but tutorial-wise, there's a little bit less there. So we really need some sort of effort on that front too. But I'm fairly optimistic about things. I mean, on the optimization side of things, it's not that we don't have a clue how to make it faster. It simply is that we haven't gone and done all of those things. Actually, one of my biggest priorities for the coming weeks and months is getting a bunch of the interesting optimizations in, which is great because I get to read papers about stuff like, SSA and dominance. It's a technical term. I'll give a talk about it sometime. Okay. The other thing is that you only get access to all the parallel stuff on the JVM. So we need to get that ported elsewhere. But that's actually planned for the very near future as well. And I reckon that'll be there within a few months. And there's actually a funded grant for doing the Perl 5 interop. So that actually has funding now. It has somebody who's on the hook to do it, hopefully. And we also have a project called V5, which is very promising, which basically is using the Perl 6 compiler tools to implement Perl 5 far enough that for a bunch of simple scripts, you can take your script in Perl 5, make sure it still runs, and then you can actually turn it block by block into Perl 6. So you can take one block and say, oh, I'm going to write this bit in Perl 6, and say use V6, and write Perl 6 code there. Or you can actually have a bunch of 6 code and say use V5. And this is coming along fairly well. We've basically taken the Perl 5 spec, Perlflower's own test suite to try and get this. So we're thinking a lot about migration strategy as well. So if I come to Fosdem again next year, which would be very, very nice, then here's the things that I hope to be able to tell you. That we'll have made things a lot faster, that we'll have got memory usage down a good bunch, that the interop actually is in place, that you don't have to choose JVM if you want to do concurrent and parallel programming, because we have that on one of the alternatives, the documentation is in better place. And I really do want to emphasize the community around this project is really great. It's the reason I'm still doing this, and I think it's the reason a lot of people are involved. And I'm pretty sure it'll stay that way. Okay, if you want to learn more, Perl6.org, or drop by the IRC channel, or drop by the booth, which is downstairs somewhere. And I'm pretty sure I've used up all the time, so I will just say thank you very, very much. If you have questions, I probably need to finish here, but do come to me afterwards, or I'll hang around the booth a bit tomorrow as well. Okay, so thank you very much.
One note, there are still 7 seats available for dinner tonight. Please check with Wendy at the booth.